In this video, we're going to continue our work of adding signed numbers. And what we said in our previous video was that if we're adding two rational numbers, all right, if the numbers have the same sign, we'll keep that sign. We'll add the absolute value of the numbers. Okay, so two positive numbers, two negative numbers, just keep that sign, add the numbers' absolute values. But if the numbers have different signs, we're going to keep the sign of the number with the greater absolute value, and then we're going to actually subtract those absolute values in order to figure out what the answer will be. Okay, and so all we're going to do here today is take those rules and extend them into working with fractions and decimals. Okay, so let's first talk about fractions. We have to recall some of our work from previous grades of working with fractions. Okay, and if we're adding fractions, remember that in order to add fractions, you must have common denominators. All right, and so in order to add, we need common denominators. So we're going to look at those denominators first thing. We're going to see if we need to make any changes, and then all we're going to do once we have common denominators is apply our rules for adding integers. So once again, if the numbers had the same sign, we will keep the sign, and we will add the absolute value of the numbers. Add the absolute values. All right. But if they were different signs, we will keep the sign of the number with the greater absolute value. Keep the sign of the number with the greater absolute value. And then we will actually subtract the absolute values of the numbers. All right, so it's very important to understand absolute value. That's a number's distance from zero. Okay, and if they're different signs, you're going to keep the sign of the number with the bigger absolute value and then subtract those absolute values. So why don't we put that into practice down here with a few examples. All right, we have our first example here. It says that 4/7 plus -3/5 is equal to what? Well, I notice here that the numbers have different signs, but I'm not quite sure exactly if the sign should be positive or negative yet because I don't know what the common denominator is yet. I can't add these numbers the way that they currently are because the fractions don't have the same denominator. I have sevenths and fifths, and a good common denominator for sevenths and fifths would be 35. So I'm going to rewrite this problem so that it uses a common denominator of 35. So my first fraction is going to be positive, plus my second fraction is going to be a negative. And let's look at the denominators to see what we did to change them into 35. 7 times 5 is 35. So do the same thing to the numerator. 4 times 5 is 20. And with the second fraction, -3/5, 5 times 7 is 35. 3 times 7 is 21. So the second fraction will actually become -21/35. And now that the fractions have the same denominator, it's easy for me to tell what the sign of the answer should be. This is a positive, this is a negative, different signs. I keep the sign of the number with the bigger absolute value, which is this -21/35. It's a little bit further away from 0 than 20/35, so I know my answer is going to be negative, but the question is negative what? Well, I know my denominator is going to be a 35, all right? And if I if I actually subtract the absolute values now, 21/35 minus 20/35 is 1/35. And so the answer to this problem, 4/7 plus -3/5 is -1/35. Okay, so again, we get those common denominators. We look at the absolute value of the number, the sign of the number with the bigger absolute value, which was this negative in this example. And then because they were different signs, we're going to subtract those absolute values for -1/35. Letter B, -2/3 plus -1/6. Again, the denominators are different. Okay, so let's get them the same, third and sixths. Let's keep sixths as our denominator. So this is going to be negative something over 6, plus I can actually keep -1/6 exactly the same. 3 times 2 is 6, 2 times 2 is 4. So we have -4/6 plus -1/6, and the signs are the same. So since they're the same, all I'm going to do is just add the absolute values. I'm keeping that sign. -4/6 plus -1/6 is -5/6. So -2/3 plus -1/6 again is -5/6. sixth. How about if we have some mixed numbers? 1 7/8 plus -3 1/2. And the first thing I'm actually going to do, I'm going to rewrite these mixed numbers as fractions. Okay, I like to work with fractions like I did in A and B, so let's do that over here. 8 times 1 is 8 plus 7, this is 15/8 plus negative 2 times 3 is 6 plus 1 is 7, -7/2. Let's get our common denominator now. Eighths and halves, we can use 8 as a common denominator, so we can keep 15/8 as it is, plus negative something over 8. Well, 2 times 4 is 8, 7 times 4 is 28. And now I see that they have different signs. Which sign is our answer going to be? Well, -28/8 has the bigger absolute value, so my answer is going to be negative something over 8. And now let's just subtract the absolute values. 28/8 minus 15/8 is 13/8. And so we could leave our answer like that, -13/8. It is in simplest form. Or we can make it a mixed number again, -1. 8 goes into 13 once with 5/8 left over. So either one of those answers would be acceptable. We just practiced adding signed fractions, and now let's practice adding signed decimals. Okay, before we do that though, let's just review our rules for adding decimals. Remember that when you're adding decimals, we must line up the decimal places. Okay, by lining up the decimal places, you will be sure to make sure that you add the place values correctly. This will make sure that we add whole values or whole numbers to other whole numbers. We will add the tenths place to the other tenths place. We will add the hundredths place to the other hundredths place, and so on. So make sure that you line up those decimal places at the beginning. When you line up the decimal places, if there are any empty spaces, we're just going to fill them in with a 0 in order to make sure that the decimal places line up. Okay, and we're just going to apply our rules for adding sign numbers like we've been doing all along. If the two numbers have the same sign, we'll keep the sign of the numbers and we'll add the absolute values. But if they have different signs, we'll keep the sign of the number with the bigger absolute value and we will actually subtract the absolute values. Now remember, when you're subtracting decimals, you have to write the number with the greater absolute value, on top when we restack our numbers. Write the number with the bigger absolute value on top. So let's apply that here to working with our decimal examples underneath. In letter A, we have -4 38/100ths plus -9,213 10,000ths. Okay, I am first looking at the signs of the numbers and I see that they are both negative, so I'm going to keep that negative symbol for my answer. And since they are both negative, all I need to do is add the absolute values together. The absolute value of 4 38/100ths is 4 38/100ths. The absolute value of 9,213 10,000ths is 9,213 10,000ths. Let's add them together. I'm going to fill in my empty spots there with a couple of zeros. And 0 and 3 is 3, 0 and 1 is 1, 8 and 2 is 10, carry a 1. 1 plus 3 plus 9 is 13, carry a 1. Don't forget your decimal point here. 1 plus 4 plus 0 is 5, and that means our final answer up here is going to be -5 and 3,013 10,000ths. Looking at letter B, we have 3 86/100ths plus -6 4/10ths. The numbers have different signs this time, so I'm going to keep the sign of the number with the bigger absolute value, which happens to be the -6 4/10ths. That number is further away from 0. So my answer here is going to be negative, and then I'm going to subtract the absolute values of the numbers in order to figure out my answer. Now, since -6 4/10ths had the bigger absolute value, I'm writing that absolute value first. So the absolute value of -6 4/10ths is 6 4/10ths. The absolute value of 3 86/100ths is 3 86/100ths. and I need to subtract the absolute values because these were different signs. Put a 0 above that 6 in order to make sure that we have everything lined up nicely. And now let's go ahead and subtract. Now 0 minus 6 we can't do, so we're going to make that a 10. We're going to borrow from the 10th place. So the 10th place is going to become a 1. The 100th place we have a 10, or a 3 rather. The 100th place is going to become a 10. 10 minus 6 is 4. 3 minus 8, again, we can't do, so we'll borrow from the ones place, make that a 5, and our tenths is a 13 now. 13 minus 8 is 5. Don't forget your decimal point. 5 minus 3 is 2, and so our answer is going to be negative 2 and 54 hundredths. Letter C, we have 574 thousandths plus negative 43 hundredths. The numbers have different signs, so I'm going to keep the sign of the number with the bigger absolute value, which happens to be the positive number this time. 574 thousandths is further away from 0 than negative 43 hundredths. So I'm going to have a positive answer, but positive what? Well, the signs are different. We need to subtract the absolute values. We'll start with the greater absolute value, 574 thousandths. The absolute value of negative 43 hundredths is 43 hundredths, and we have to subtract because the signs were different. Let's put a 0 under that 4 so that everything's lined up. 4 minus 0 is 4. 7 minus 3 is 4. 5 minus 4 is 1. Bring down your decimal. 0 minus 0 is 0. And again, our answer was going to be a positive in this example because the positive number had the bigger absolute value. So our final answer is going to be 144 thousandths. So the rules are exactly the same when you're working with signed fractions or with signed decimals. Same signs, keep that sign, add the absolute values. Different signs, you're going to keep the sign of the number with the bigger absolute value, and you will subtract the absolute values.